Hey everyone, and welcome. We're constantly surrounded by apps, websites, and all this digital magic, right? But how does it all really fit together? Well, in this explainer, we're going to connect those dots for you.
It really boils down to this one huge question. How do you go from one single line of code to a massive service that people use all over the world? That is the exact journey we're about to take together.
Exactly. We're giving you the highlight reel, the panoramic view. We've pulled the most crucial ideas from software, the cloud, cybersecurity, and business so you can see how it all clicks into place. Okay, let's dive right in.
We have to start at the very foundation, right? The actual language that tells computers what to do in the first place. You know, every single app or program, no matter how complicated it seems, is built on algorithms. And honestly, the best way to think about an algorithm is just like a recipe. Your data? That's the ingredients. The algorithm? Those are the step-by-step instructions to get to your final dish. Simple as that.
And to write those recipes, programmers really only use a handful of core tools. You've got variables, which are just containers to hold your ingredients. Data types tell you what kind of ingredient you have. Is it text? Is it a number? Then you have conditional statements, which are your basic, if this happens, then do that kind of logic. And finally, loops. Oh man, loops are a huge time saver. They just automate any repetitive task.
Now this brings us to a really powerful idea called object-oriented programming. The analogy here is perfect. Think of a class as the blueprint for a car. It defines everything, what color it can be, what engine it has, that it can start and brake. The object is the actual car you build from that blueprint. This approach is what lets developers build incredibly complex software in a way that's organized and reusable. It's a game changer.
Okay, so we know how to write the code, how to make the blueprints. But how do we go from those individual pieces to a full-blown application that the entire world can actually use? That's our next step, building and deploying it.
This isn't just some chaotic, messy process. It's very structured. It's called the software development lifecycle, and it's kind of like the architectural plan for building a house. You plan it out, you design it, you do the actual building, the coding, you test everything to make sure it's solid, and then you open the doors. Following these steps saves so many headaches and costly mistakes down the road.
So once that digital house is built, it needs a place to live, right? And for just about every modern application today, that place is the cloud. Think of it as a global network of powerful computers, all working together to let software run at a massive scale, accessible from literally anywhere.
And when you look at the big cloud players, you start to see they're all solving the same basic problems. Take storage, for example. They both offer this massive scale storage for things like files and images. Amazon calls their containers buckets. Microsoft calls theirs, well, containers. The names might be different, but the goal is exactly the same. Give our data a secure and infinitely scalable home.
All right, so we've built our software. We've put it out there in the cloud. The next absolutely critical question is, how in the world do we keep it safe?
Here's the thing. To be a great defender, you have to think like an attacker. And the cyber kill chain is basically the attacker's playbook, broken down into 7 steps. Security pros live and breathe this model, because if they can understand an attacker's process, they can build defenses to break the chain at any one of these stages.
And trust me, the threats are very, very real. Here are 2 of the most common ones you'll ever see. A SQL injection attack tries to trick the database behind a website into spilling its secrets. And cross-site scripting, that one injects nasty code right into a website to attack the visitors of that site. It just goes to show you why writing secure code isn't just a good idea, it's non-negotiable.
So how do we fight back? How do we protect our data? Well, cryptography is the absolute bedrock of digital security. It mostly comes in 2 flavors. Symmetric encryption is super fast. It uses one shared key, kind of like a password everyone on the team knows. Asymmetric is a bit more complex. It uses a public key that anyone can use to lock a message, but only a single corresponding private key can unlock it. That little bit of magic is what secures so much of what we do online every day.
All right, for our final section, let's tie all this amazing technology back to its ultimate purpose, driving business and creating actual value in the real world.
When you strip everything else away, this is why it all matters. The code, the cloud, the security, it is all in service of one primary mission, taking raw data and transforming it into smart, actionable decisions that help a business grow and succeed.
So how do modern companies do this effectively? The answer is a movement called DevOps,
which is all about bringing the software development and IT operations teams together. It's really built on 4 key pillars. It starts with a culture of collaboration, it's powered by automation, it's guided by constant measurement and feedback, and it gets better through sharing knowledge.
And this is it. This is the ultimate connection we've been building towards the whole time. DevOps isn't just some techie practice, it's a core business strategy. By using these principles, companies can deliver better software, way faster. And this brings us full circle, linking that single line of code we started with directly to real-world business success.
So as we wrap up, I'm going to leave you with this question to think about. After seeing how all these pieces, the code, the cloud, security, and business, all snap together, what surprising connections did you make? What new questions popped into your head? Because that curiosity, that's the real starting point for getting a deeper understanding. Thanks for coming along on this tour.